with us Dr. Mrs. Maitri Dutta, who is professor and head of Department of Electronics and Communication Engineering at this institute. And she has to her credit about 20 years of experience in teaching and research. She has been guiding number of PhD dissertation and ME dissertation, and she has also presented number of papers, large number of papers, I would say, in various national and international journals and conferences. So we have with us now Dr. Mrs. Maitri Dutta. She will be throwing light on some of the areas of research in electronics and communication engineering. Dr. Mrs. Maitri Dutta.
Good afternoon, everyone, and all the remote centers. So, at the end of the day, you must be tired listening all the lectures from morning onwards. So, anyway, I am here today just to give you some information about research areas in electronics and communication engineering, and I hope so that I will be able to give you some new concepts in electronics and communication engineering side so that you can do work in that areas. If you see that what are the broad research areas in electronics and communication engineering, so we can work in electromagnetics, applied electromagnetics and RF circuits. We can work in communications, computer vision, which considers the image processing also. Then control systems, embedded systems, VLSI, MEMS, specifically in MEMS, optics and photonics. Then there is new side, that is plasma science and engineering, which considers the nano science and nanotechnology and nanomaterials, power and energy, quantum science and technology, robotics. Somewhat it is mixed with physics also. Robotics is a challenging area. Then signal and image processing and machine learning. Then solid state devices. And finally, we can work now in IoT. My area is digital image processing and digital signal processing. I will just give you the overview that in what are the different areas where we can work upon. We can work upon in biomedical imaging. Maybe most of us are working in biomedical imaging and ultrasound, in MRI and all these images, ECG or EEG signals. So we can work nowadays. The researchers are going on basically in MRI images, that is magnetic resonance imaging, and also the CT scan images. CT scan, as we know, that computed tomography, that is known as your CT. CT means computed tomography. Everybody we know about the CT scan images and all. There's a machine which gives, takes out the images from our body wherever we are doing the CT scan, and it gives some advantageous some informations more than X-ray. Then we have the position emission tomography, that is known as your PET, right? This is a testing area, or this gives the images which actually takes care of the positions of our the different organs in our body. Another is your optical coherence tomography, that is known as your OCT. In nowadays, the many papers in IEEE journals or IEEE transactions, you will get many research papers on this OCT, that is known as optical coherence tomography. That is basically, that image gives us the cross-sectional images of our retina. So actually doctors and the engineers, both these professionals are working together with this type of images that is known as our OCT. That is basically the optical laser, the signals, and it will take out the cross-sectional images of retina. And ultrasound, definitely we are working with ultrasound images and different anatomical and functional processes of the human body that we of course know. Another area is our computer vision. It is the science and technology of teaching a computer to interpret the images and video as well as typical human. Technically, computer vision actually that includes the field of image or video processing, pattern recognition, biological vision, artificial intelligence, augmented reality, virtual reality, mathematical modeling, sensors, optimization, photography, every field. Every field it is combining basically the combined field is known as your computer vision. Image segmentation and classification. Specifically in images, we are working in various categories. For example, image enhancement, image segmentation, image classification, image restoration, image registration, morphological image processing. So there are so many areas in image processing only, and you can get near about 1,000 papers in IEEE transactions in different area. So image segmentation is one of the area which I am working, and my students are working in remote sensing images segmentation. So with this we are working with some software that is known as your eCognition software. eCognition, ECOGNITION, eCognition software. That software is basically very high resolution segmentation software. So in case of the remote sensing images, since we need a very high resolution segmentation or high quality segmentation, so that we can differentiate with the regions, whatever regions we have. For example, if you are taking the area of picture of this Chandigarh in sector 26 images, wherever we are there in night, so we can differentiate that in sector 26 in which area Nighter Chandigarh is situated, in which area the Sabji Mandi, that is grain market, is situated, in which area the Institute for Blind is situated. So to differentiate all these regions, there is a high capacity and high segmented resolution segmentation software is required. So we are working with eCognition software. And also the image classification is also one of the area where the many research people they are working. Multi-resolution techniques, for example, we are working with, many of us are working with this wavelet transform. That is actually one example of multi-resolution decomposition technique. So multi-resolution methods are very broad area, and essentially meaning that an image and video is modeled, represented, compressed, extracted in more than one scale. So multi-resolution techniques, in multi-resolution image processing also somebody is working, some are working. Remote sensing, as I have told you, this is a science of capturing data of the earth from airplanes or satellites. So it also one of the area where the researchers are working upon, and a vast amount of information is generated by remote sensing. But main problem when we work with the remote sensing is the collection of the the data. So if you want to work with the remote sensed images, you should be very careful that from where you will get the data, because data is much important. Without getting the high density of data, you cannot work with accuracy with any of the data. So in image processing, I will suggest that if anyone wants to work in image processing, be sure that you can get the data very easily. Otherwise, in government of India also, they have loaded many type of data in case of this Sakshat web portal, that is basically for the data analysis. So if you want to work in data mining or data analysis or big data analysis, so you can take the data from the government web portal also. There is a lot of data has been put nowadays by the government in Sakshat web portal, and those data are the normalized data. So these data are very much, there's all the metadata are available, and those data are normalized. So you can take data directly and you can work with. But for images, definitely, for example, if you are working with iris, if you are working with any other, for example, characters, if you are working with fingerprints, if you are working with some, retina, if you are working with some ultrasound images, so you should be very careful that you can get the good data and the, believable data. If you are working with one doctor, then you can get the, reliable data from the doctors. But definitely the data from the doctors are not normalized. They generally take data from directly from the camera. So you have to be very careful when you use the data directly that you get from the doctors. So the whatever images you get, or the whatever the data you get in case in Google's or some other directory from the any scientist in the outside world, outside India or some other university, that those data you can you can be reliable with those data, and you can use those data. Scientific imaging refers also to working with 2 or 3 dimensional imagery taken for the scientific purposes, in most cases acquired through the microscope or remote sensed images taken at a distance. So that is also one area. Video analysis, that definitely comes under computer vision, but that also involves the automatic representation or interpretation of digital video using computer algorithms. So in computer vision, we can get many area, for example, the target identification, target tracking, some video, in case of the security purposes also, sometimes we can use it. For example, one tank, it is coming, and how you can capture the images or the video of the tank, and how can you recognize that it is a tank not from your country, it is from other country. Such type of target identification, tracking. So this type of uses you can do with the case of this video analysis. And for the tracking purposes, some of our students also were working. They were working in Kalman filter. So this Kalman filter is a very much that is specifically used for this target identification and tracking identification. So these type of work are going on. In image restoration also, many work is going on. For example, there are 2 different restoration process: blind restoration and non-blind restoration. But definitely work is going on in blind restoration, which is a difficult topic, because if you don't know the image, original image, but then also you are restoring that image, so it is a tough area, and many work is going on in blind restoration. My students are working in blind restoration. They are working with modified maximum a priori method, and this is basically we are using the optimization and also the this blind restoration method to get the modified one in case of the images. So recently I have just took out that in 2015, near about in February, before February 2016, or in published in December 2015, some papers I have just taken out, that just to discuss with you that what are the papers, what are the researchers are going on nowadays. Iris pattern, that is a very old researches that is going on nowadays also, that is to iris recognition. So basically many filters we are working with this iris recognition, but recently the wavelet transform and the Gabor filter, the combination of Gabor filter and the wavelet transform, that those methods have been used for biometric iris recognition system. And what are the advantages of iris, because with the irises the recognition of a particular identification of a particular person is very much easier rather than the other organs, because iris is very much unique for each and every person. Next is your speech compression. So this has been published on December 6, 2015 an IEEE transaction, and this gives a novel method of speech compression and the transmission. This method actually saves the transmission bandwidth, and it generally uses the low pass nature of the speech signal. Speech signal as a or the audio signal as a one quality that it has all the information, maximum information into the low frequency signals. So every time we just cut the high frequency signals by passing through a low pass filter, and then we exploit those signals to use this compression or the some extracting the information from the speech signal. So that is a speech compression also is in high demand nowadays, because we have this Facebook and LinkedIn and any other, all these other social sites where the videos and communication and multimedia images we send. So that is very much required, that is speech and images and video compression, it is in very much demand nowadays. Another is your, you must be knowing about the wearable biosensors, and you must have heard about also, some of you must have heard, must have worked with that. That is your wearable, some, sensors we wear. With this, you can measure your pressure, you can measure your sugar, you can measure your something that is hemoglobin, you can measure some other contents also. So wearable monitoring devices allow generally the continuous and the intermittent monitoring of the physiological signals is in critical conditions, and these are basically the totally non-obtrusive devices that allow the physicians to overcome the limitations of ambulatory technology and provide a response to the need for monitoring the individuals. Another area is your multi-sensor fusion, because we know about the sensors, we know about the wireless sensor nodes, we know that different sensors we can use to take out the data from the sensors, but now we can work with the multi-sensor fusion and the integration. For example, that is fusion has a this fusion from information from sensors with different physical characteristics such as light, sound, etc. When you combine all these sensors, then it enhances the understanding of our surroundings and provide the basis of planning, decision making and control of autonomous and intelligent machines. Many ME students of our department are working with sensors, and they are working with the carrying out the smart homes. 7 or 10 10 systems they have done automation. For example, they have done with automatic light on, then they have done with automatically your fan should be be switched on. Then they have done with if it is a dark, then automatically the light will glow. Then if it is some water is coming down, for example rain is coming down, then it will sense and it will give an alarm that it is raining, then you should take out your clothes, whatever it is outside, then you should take it back. And similarly the bells they have done. So similarly there are so many works, combinedly you can work with the light, sound, with some other side also. And all this multi-sensor fusion is very much in demand nowadays, and you can integrate it. This is, I have told you, just as a project, but you can do as a research work. From algorithm point of view, you can do the research work for this multi-sensor fusion. Then another one is your gigabit fidelity, that we know that is gigabit wireless connectivity. We know that wireless connectivity is one of the wireless connectivity is the one of the main area of the communication side. And nowadays 4G LTE, then 5G, these are in a hot topic. So one of the topic is your gigabit fidelity, that is known as your gigabit wireless, and they are able to transfer the audio and video at the rate of 5 gigabits per second, 10 times than the current maximum wireless transfer rate, at the 1/10 of the cost. That means they are taking care of the cost also, and they are taking care of the speed also. So this is also one of the hot topic. And another area in electronics, that is your hotspot applications, to design the reduced size antenna for the hotspot applications. That also in one of the uses, one of the research areas. This University of Michigan, they are working with this electronic tongue. This electronic tongue is basically one device which can, test besides the 4 tests in the human tongue. So they can test any type of liquid or any type of gas. So this actually basically to analyze the substances present in, the blood or urine, or some, poison in water, some poison in drinking water, some, unused material, unwanted material, we can say, in water, or some in drinks. So these type of devices can carry out it can test it, and it can give this such type of material are present in this drink or in this water. So it is applicable in liquid and in gas. This is, of course, is in research area that researchers are going on in RADLab, RADLAB. RADLab, this is the laboratory name in University of Michigan. So they are working with this electronic tongue. Another area is your single electron transistor, that is known as your SET. Many of you are working with VLSI design and transistor in microchip level. So you can think of the working with the single electron transistor. This is basically discovery is with the Coulomb blockade phenomena, and it is telling that which works above the liquid nitrogen temperature. It works with a high temperature, and it can bring the revolution in electronic science. This is also under research, so you can think of it, and you can just go through many papers either have been published in IEEE and the transactions, or this electronic transactions, electronic, the letters or the magazines and all these things. You can get many idea for the single electron transistors. Another is your stratolite. Stratolite is basically that this is one term that is known as your senseware. So senseware, this is actually named trademark of senseware. These are telling that we can get high altitude and free airship that provides the communication in stratosphere. So they are basically they are currently testing this to include a launch of satellite into the stratosphere, that is known as your stratellite. So if somebody is working with that communication and satellite communication, they can just think of it that there is a new topic that is working with, that is stratellite. Another very interesting topic that are going on, that is everybody, you must be knowing about the ad hoc network and ad hoc network protocol. Previously we will have that proactive protocol and reactive protocol like DSDV OLSR. These were the proactive protocols, and reactive protocols like AODV, and hybrid protocol like TORA and JRP. These are all the different types of protocols. Now they are telling that optimization algorithm are connected with the network protocol to produce this hybrid protocol that is known as your ANTIHOCNET, that is known as your ANTHOCNET, not ANTHOCNET. This is ANTHOCNET, that is ad hoc and the ant colony optimization. Similarly, bee colony optimization is also there. So all these optimization are connected with the ad hoc network, and they have created the protocol that is known as your ANTHOCNET algorithm. So with the ANTHOCNET algorithm or some other bio-inspired protocol, they are working with this proactive and the reactive schemes. So this is also another topic in case of the networking or the communication, where you can work with it, because be ad hoc and ad hoc ANTHOCNET, and also you can create your own network. There are so many bio-inspired optimization algorithm are there. So if there are two algorithm have been created, now you can think upon the third one. So such type of the new or the novel method or the hybrid method you can think upon to work with, so that you can get the new and the established protocol, and you can compare with the existing protocol, so that your work gets validated. Besides this, there are some other area, that is your applied electromagnetics and RF circuits. Applied electromagnetics also plays an important role in a variety of modern applications, ranging from wireless technologies and communication, and also in the life sciences and the transportation and others. And in MEMS also we are using antenna and wave propagation, also we are using this RF circuits and all. Control system, that is a very the old area, but it is an very existing established area where you can work with in control systems. And with this microcontroller and all, and without the microcontroller you cannot think of any device. So this controller design is basically the part of the control system only. And another is your controller design comes under the embedded system design. So in the computers, in vehicles, wireless sensors, then medical devices, wearable fitness devices, these are all examples of the embedded system design. And designing embedded system is a huge challenge, because there are so many requirements are there. So it has to be small, tiny, then high performance, high capacity, then it should be the less costly, then it should be the reliable. So many, the challenges are there with the designing of this embedded system design. You have to take care of all these properties. So it is not a easy area. It is a very tough research area. Wherever you want to design something embedded system, so you have to be very careful that all the the characteristics you should meet. Signal and the image processing and signal I have already discussed, but some other topics, for example, the GPS and the location aware cell phones, intelligent automotive sensors, multimedia devices, forensics, information forensics, that is also, that forensics in your body, that also can be the one of the research area, how to take out the forensics or the unwanted material from your body. 3D medical image scanners, that is also, it is algorithms for this cardiac imaging, that is also the one of the research area it is going on. Another I had discussed, that is your plasma science and engineering. Plasma science and engineering is the discipline investigating the fundamental transport and reaction chemistry of the partially ionized gases. This is the combination of the chemistry and the engineering, and their application to technologies ranging from lighting sources, lasers, and sensors to material processing. Biotechnology also, sometimes we were using the plasma science, and microelectronics fabrication and space science is also sometimes they use this plasma science technology, right? This is also one of the area. Robotics, as I have told, there are so many work going on in the research way in robotics, and as I have told, some universities are also working in robotics. Recently we had done in electronics and communication engineering department, we have done the international seminar on robotics. So we had connected NASA, and in NASA robotic division, they are very much work going on in robotics, and in University of Texas also we had connected with the with internet, just like as we have connected you. So such like that we have connected with University of Texas, and they are telling that they are working with, that is known as your bipedal robotic locomotion. Bipedal robotic locomotion, it is telling that the robot can work on two legs with the agility of a human, just like as simple way we walk as a human being, how in a very flow way we can work. So robot also we will work just like as a human, just with the same agility work like a human being. So they are working on this bipedal robotic locomotion. Another area I'll just tell you about the IoT, that is Internet of Things. There are so many work is going on in Internet of Things, and if any one of you are doing the research work and you have started research work, so I will suggest that you can work on Internet of Things, because there are so many issues and challenges. You can take any challenges and you can work on it. So basically the IoT is the very complicated heterogeneous network. So to interoperability between the devices in the internet, that is a challenging task. So the standardization is very much important, though some standards are already there, like 6 low span. This is one of the standard we use in IoT, but still there there are so many standards you may work with when on the security standard, communication standard, identification standard. So my some two students are working with the security standard. So we have picked up the security standard, but similarly you can pick up the identification standard also, because identification challenge is one of the main challenge in IoT. Basically in the physically, when we use the the identification, we use QR code or the RFID code, but in case of IoT that is not possible, because in every devices in the internet you do not know that how to identify those devices, whether those devices are important devices and they should be in your IoT or not. So there should be some global ID schemes in the identity management, identity encryption, identity encoding, pseudonymity, various authentication of the parties. So there are so many areas, these are already there, challenges are there in identification of the devices in IoT. Similarly, security and privacy also, there are very much lacuna is there. IoT devices, because these are outside the traditional security perimeter, so need to secure the device. Not only the devices, you should secure the devices also, you should secure the gateway also, you should secure your cloud also, and you should secure your communication protocol also. So there are so many security steps are there. You can take any of the security, so that, for example, we are working with the security communication protocol, but similarly you can take the security, the gateway security or the device security or the cloud security. That was also many people are working with. Heterogeneity has a great influence over the protocol and the network security. Similarly, another term is your privacy. Privacy is very much important. For example, you are connected with one doctor. I'm giving one example that why privacy is needed in case of IoT. For example, you have a chip, right, in your heart. We have connected one chip nearby your heart, and you are connected with some doctors, and if there is any problem is there in your heart, then automatically that chip will give the information to the doctor. But since you are in IoT, your device is in IoT, so it will be this information will be broadcasted to everywhere in the internet, and there are so many parties are there in the internet, and automatically you can get the information that I will help you, you have the heart attack, or you have the this type of ECG signals are there, and I am telling you that what should be done, what should be done. So definitely you will get there are so many communications you will get from the unwanted persons or unwanted devices. So that's why the privacy is very much important in case of the IoT. Next is your trust and the governance. So trust is very much important, that you can work with this concept, that trust in the interaction between the entities, where we have to deal with the uncertainty about the future actions. So when we are in IoT, or we are connecting with the many devices in the internet, how you can trust upon with those devices. Privacy is required, security is required, and trust is also required, right? Then another is your governance. That is your it is a double-edged sword that must be wielded with care. That means you have to be controlled. The control also must be there, so that you can govern you can take the govern of the whole IoT. And another concept in IoT, that is your green IoT, that is your energy efficient IoT. So someone of you can work with the energy efficient IoT. That means in IoT, how the energy can be saved. That is also can be one of the idea or one of the research area in IoT. So it is a critical design goal for IoT devices such as wireless sensor. This is very much needed, because whenever we work with the WSN or the wireless sensor nodes, the main aim is to take out the efficient energy out of it, so that the power consumption will be less, energy consumption will be less, and it can give the accurate data. So that is there is a need to have this energy efficient techniques in case of this IoT. And another is you can definitely combine the IoT and the cloud computing. That is very much needed, that cloud can be combined with IoT. And another is a context aware for IoT computing. That is actually new topic, how IoT you can connect with the data mining. That means, or knowledge recovery. For example, you are not only giving the information or the data, that is you are sending the data from one to another, but you can basically you can work with the metadata, or the data about data, or the information or the context of the data, and you can take out the knowledge from the data, and you can take out the intelligence or the decisions, and how to analyze the data, and how you can take the decisions from the data. So knowledge recovery or the knowledge discovery and the IoT, so that you can combine. So these are the main the areas which we can work upon. Definitely I have just given you the overview of the some areas that you can work upon, but automatically there is areas are not so much limited. There's huge areas in electronics and communication that you can work. So thank you so much, and this I have just given just an overview, and I'm sure that I was able to give you some areas which your faculty members and anyone can work with. And if you want any type of guidance from our side or from NITER, we are always there to help you. You can just get the email ID and you can contact with me. Thank you so much.
So thank you, Professor Maitri Dutta, for giving number of ideas about conducting research programs in electronics and communication engineering. So friends, we are now going to close this session, and before that there is some small announcement that tomorrow at 9:30 the session will start. All the participants are requested to be right in the conference hall or the seminar hall of your respective institution, and I request all the coordinators to give me the number of participating teachers who are participating in this particular program, institution wise. And if you have any query, you are welcome. Yes, any query, any question? So DAVIT Jalandhar, how many participants are attending this program?
20 participants are there.
20. Are
Yeah.
they present right now?
Yeah, you can see them.
Okay. Then YMCA University of Science and Technology, Faridabad, how many participants are there? Anjay?
32.
32. 34. So all the 34 will be participating in all the 10 days. Okay.
All 34
All
people
participating in the,
Yes, sir.
okay. Okay. Then as PP's Siddhartha at Vijayawada, PV Institute of Engineering and Technology, Vijayawada,
Sir, 13 participants, sir.
only 13, 1 3.
Yes, sir.
Okay. Then Gandhi Academy of Technology, how many are present? Gandhi Academy of Technology,
Now, and the 25 have been registered.
25.
Yes,
How
sir.
many are present right now?
18, sir.
Okay. So please tell 8 people to be punctual and be regular from tomorrow onward.
Okay, sir.
And Panipat Institute of Engineering and Technology, how many participants? Panipat Institute of Engineering and
Sir,
Technology.
24 participants.
So will they be participating during all these 10 days?
Certainly, sir, they'll be there for all the days.
Okay, ma'am. Thank you. And CV Raman College of Engineering. CV Raman College of Engineering.
Yes, 19 participants.
19. SSIT Derabasi. SSIT Derabasi. Sukhmani Polytechnic Institute. How many participants are?
Sir, 25 participants will be there.
Okay. Then Swite College of Engineering. Swami Vivekananda Institute of Engineering and Technology. Swite Swami Vivekananda Institute of Engineering and Technology. How many participants are attending? Dronacharya Group of Institution, Noida.
We have 25 participants from our institute plus 5 participants from other institutes. Sir, actually today we have university exams in our college, so most of the participants have been assigned with exam duty, but
Right
they were there before the lunch.
Right now, only 2 participants are present.
Yes, sir. So other
So-
participants have been assigned with exam duty. They were there before the lunch.
But kindly ensure that this should not happen tomorrow, please.
Okay, sir.
Okay, Chandigarh University, Ghadua. कितने? 17. 17. Okay. Then IEC Group of Institution, Noida.
Sir, am I audible?
IEC, हाँ जी. How many participants are attending?
So from our side, there are 80 numbers, but right now due to exam, university exam, we are not able to. They are not able to attend this session. So tomorrow onwards, I am sure you. From tomorrow onwards, they will be present.
So because we will not issue the certificate to those who will not attend the program regularly.
Definitely, sir, definitely.
Dronacharya College of Engineering, Gurgaon.
So 16 participants.
16.
Yes, sir.
Okay. Then TIT S Bhiwani. TITS Bhiwani. So TITS Bhiwani is not connected. How many participants are attending? Voice is not audible, sir. Voice is not audible. प्लीज आप अपने लैपटॉप के पास जाइए, वो जो इनबिल्ट है वहां से बात करिए. हाँ जी. हाउ मेनी पार्टिसिपेंट्स? नॉट ऑडिबल.
सेवन.
ओनली 7.
नहीं 10.
27.
22.
So 27 are present.
26.
25. Okay. And Government Engineering College, Bharatpur.
Yes, sir.
How many participants are attending the program?
29 participants are attending the program here.
Okay. So they will continue throughout the this program.
Yeah, absolutely, sir. They will continue all the program.
And what about Swite College, Swami Vivekanand Institute of Engineering and Technology? Any connected? नहीं है. Okay, thank you very much. So